In this video, we are going to use Feynman's method to find I equals integral 0 to infinity sine of x over x dx. We define IA equals integral 0 to infinity sine of x over x e minus e to the power of minus ax dx, and with the assumption that a is greater than 0. If a is greater than 0, this integral is convergent. We take the derivative of both sides of this equation and we switch the order of the derivative and integral. Theoretically, it has to be explained. At this stage, we assume we are allowed to. Therefore, I prime of a is integral 0 to infinity of derivative of this function with respect to a, which is minus x times sine of x over x e to the power of minus ax dx. This integral can be found using by parts method, and it is negative e minus e to the power of minus ax times cosine of x plus a sine of x over a2 plus 1 from 0 to infinity. Limit of this function as x approaches infinity is 0. Therefore, the integral is the value of this function at x equals 0, which is negative 1 over a2 plus 1. Since I prime is equal to negative 1 over a2 plus 1, IA would be negative tan inverse of a plus constant. Limit of IA as a approaches infinity is the same as limit of this integral. Again, we swap limit and integral with the assumption that we are allowed to do this. Theoretically, there are some conditions and it is not always possible. This limit is going to be integral 0 to infinity of limit of sine of x over x e to the power of minus ax dx as a approaches infinity, which is integral of 0 to infinity 0 dx, that is 0. IA is negative tan inverse of a plus c. As a approaches infinity, IA is 0, negative tan inverse of a is negative pi over 2, and c is c. Therefore, c is pi over 2, and IA can be written as negative tan of a plus pi over 2. We are looking for integral 0 to infinity of sine of x over x dx, which is I at 0. I at 0 is negative tan inverse of 0 plus pi over 2, which is pi over 2. Therefore, integral 0 to infinity of sine of x over x dx is pi over 2. One more time, we swap the derivative of an integral, and we swap the limit and integral. These are not always true, but for this function, we are allowed to do so. Thank you.